Here are a few rules to follow when you are in the lab. Do wear goggles, your lab coat, gloves, and closed-toed shoes. Properly dispose of your waste in the labeled bins. Label all of your chemicals, and use the proper tools and glassware during the experiment. Do not sniff the chemicals, mouth pipette, wrestle or threaten to throw acid at people, dump all of your waste down the drain, or make meth. During today's experiment, we are determining the effect of different factors on reaction rate. We will be exploring the effect of temperature, concentration, and surface area. For our first experiment, you will need 6 test tubes, 3 400 milliliter beakers, 15 milliliters of 0.1 molar hydrochloric acid, 15 milliliters of 0.1 molar Na2S2O3, a stopwatch, or in our case, we used a phone to record our times, and a Bunsen burner and ice for the ice bath. Colleen is currently preparing the solutions for experiment 1. Once you have the solutions prepared, place 5 milliliters of the 0.1 molar hydrochloric acid in each of the 3 test tubes. With the remaining 3 test tubes, place 5 milliliters each of 0.1 molar sodium thiosulfate. Put these aside and make your water baths. We used a hot plate instead of a Bunsen burner for more even heating. So place a 400 milliliter beaker filled 2/3 of the way with water on the hot plate and heat until it is approximately 70 degrees Celsius. Fill another beaker with room temperature water 2/3 of the way. Fill the last beaker with water cooled by ice to about 10 degrees Celsius. We did not know how long the experiment would take, so we made one large master ice bath to pull from in case the water would not stay cool enough during experimentation. Place one of each tube, hydrochloric acid and sodium thiosulfate, in each of the 3 baths to establish thermal equilibrium. When this is established, have one partner combine the 2 solutions. The other partner should begin timing the second the solution touches until the solution turns cloudy. Then, when the reaction is completed, take the temperature. That will be the reaction temperature. Repeat this for the other 2 water baths. Compare the data to see how temperature affected the reaction rates of each solution.
I wish that I could be like the cool kids, 'cause all the cool kids, they seem to fit in. I wish that I could be like the cool kids, like the cool kids. He says I'm talking with a big smile, but they haven't got a clue. Yeah, they're living the good life, can't see what he is going through.
Second experiment, you will need 3 100 milliliter beakers, 10 milliliters of each solution, so 10 of 0.5 molar, 1 molar, and 1.5 molar hydrochloric acid, a stopwatch, and 3 1-gram strips of MG ribbon. Place 10 milliliters of 0.5 molar hydrochloric acid into one of the beakers. Do so for 1 molar and 1.5 molar hydrochloric acid in the remaining 2 beakers. Add one of the 1-gram strips of MG ribbon to the lowest molarity hydrochloric acid and start the timer. Constantly swirl the beaker until the last trace of MG has disappeared. Stop the timer once this has occurred. Repeat for the other 2 beakers. Compare the data to see how concentration affected the reaction rates of each solution.
You spin my head right round when you go down, down.
You spin my head right around when you go down, down.
Hey, walk out the house with my swagger, hop in that whip, yo, I got places to go. People to see, time is precious, I look at my Cartier out of control. Just like my mind where I'm going, the women, the shorties know nothing but clothes. No stopping at my Pirelli's on, unlike my jewelry that's always on. I know the storm is coming, my pockets keep telling me it's gonna shower. Call up my homies, it's on and popping the night cause it's meant to be ours. We keep a fadeaway shot cause we ballin' and spittin' up Patron every hour. Look mama, ow, you.
For the last experiment, you will need 20 milliliters of 2 molar hydrochloric acid, 2 100 milliliter beakers, a stopwatch, and 2 grams of chalk. Add 10 milliliters of 2 molar hydrochloric acid into each of the 2 beakers. In the first beaker, place 1 gram of solid chalk, which can be found in any classroom, and start the timer. Swirl the beaker continuously until the reaction is over and it stops bubbling. Stop the timer when this occurs. Repeat with the powdered chalk in the other beaker. Compare the data to see how surface area affected the reaction rates of each solution.
But I'm finding out love's unreliable. I'm giving all I got to make you stay, or am I just a roadblock in your way? Cause you're a pretty little windstorm out on the boulevard, something like a sunset. Oh yeah, a shooting star. And I might drive myself insane if those lips aren't speaking my name. Cause I've got some intuition, or maybe I'm superstitious, but I think you're a pretty sweet pill that I'm swallowing down. To counter this addiction, you got me on a mission. Tell me darling, can I get a break somehow? Could I say no? She's got a love like whoa. Girls got a love like whoa. I kinda feel like it don't make sense, cause you're bringing me in and now you're kicking me out again. Love so strong, then you moves on, and I'm hung up in suspense, because you're bringing me in and then you're kicking me out again. It's like a hurricane speed train, she's a moving car, catch her in the fast lane. Oh, I gotta know, can I keep up with her pace? Kicking into gear when I see that face. You can take up all my time cause you're the only one that can make a storm cloud break, pulling up the sun. And I can't get caught in the rain. Can I get your lips?
When all of your experiments are completed, take your data and compare the results. You should be able to determine how each of the factors affect reaction rate. If your data does not turn out the way you predicted to, that's okay. There's no such thing as incorrect data. Remember to dispose of all of your waste in the proper waste bins and clean up your station when you are finished. We hope you enjoyed doing science with us today.